Hello, children. Today, let's try to give a quick recap to myopia and hypermetropia, the two major eye defects, covering the numerical and the quick tip for solving the numerical on each. Now we know what is myopia. In myopia, basically, the converging power becomes more. So if the converging power becomes more, so the light rays which are supposed to meet on the retina, they are not able to meet on the retina. They are falling before the retina itself, causing the blurry vision. So the nearby object, right? If the object is nearby, there is no problem. The image falls on the retina itself. But if the far rays are coming from infinity or a distant object, then the convergence is happening before the retina. The two main reasons, either the eyeball is longer than normal. So if the eyeball is longer, that means this size, the circumference becomes more. So basically, then the convergence, effective convergence is more because the rays are meeting before the retina. Or it could be over curvature at the cornea itself. Over curvature means, again, the convergence will be more. If the convergence is more, that means the light rays are quickly converged at a very high angle. So they are not able to meet at the focus. They meet before the focus itself. So in that case, what do you see? So at the retina, you'll not be able to see the clear image. You see the blurry image, right? You only see these blurry images on the retina. So what is the correction? So we know that we use a concave mirror because the convergence is more. To counter the excess convergence, we add an effective divergence, right? So diverging lens means a concave lens is placed, of course, according to the person's uh, ability, how much error is in the eye. Accordingly, the doctor will prescribe that. And we know that the focal length of the concave lens is negative. So that is why whenever you are asked the question of the correction for myopia, so always remember that concave lens with a negative focal length, or you can say with a negative power, right? Sometimes we say, I have a negative power, I have a positive power. This is a reason. Next is, let's look at the numerical quickly. Now, the far point of a myopic person is given to be 150 centimeter in front of the eye. We have to calculate the focal length and power. Always remember, children, in case of myopia, U will always be taken as infinity. U is taken at infinity because ideally the far point should be infinity. This is where the object is. So object distance remains at infinity. And this, the far point of a myopic person which is given, you take that as V always. And both V and U are negative. But effectively, what happens is when you put the formula 1 by F is equal to 1 by V minus 1 by U. Now, so children, we know that 1 by infinity is equal to 0. So this component is basically holds no value here, right? 1 by U becomes 0. So basically your 1 by F is equal to 1 by V. So in this case, 1 by F is equal to minus 1 by minus 1 by 150, which means that the focal length is minus 150 centimeter itself. So basically we can just quickly say, if it's an MCQ, that whatever is V, the value of the image distance given, that will come out to be same as your focal length in case of numericals with myopia. And then you can calculate the power by doing the reciprocal of this. So you will get 1 by minus 1.5, which will be minus 0.67 diopter. Now let us look at hypermetropia. So hypermetropia is just kind of opposite problem. You can see the distant objects clearly. So that means your distant far point is fit, but nearby objects is a problem. So like someone is able to see at 25 centimeter distance from the eye, ideally. But a person with hypermetropia may be able to see at 50, at 60, or maybe at 42. Depends on person to person how much the near point is shifted. Now this happens because of two major reasons. Either the eyeball becomes shorter. See, now if the eyeball is usual length, then the rays will normally land on retina. But if the eyeball itself becomes shorter, so then what will happen? The rays will pass the retina. And that's why the focus shifts behind the retina, and then again on the retina, you don't get the clear image. You see a blurry image. Okay, so this is the first point. Or the cornea can be too flat. So again, if the cornea is too flat, then what will happen? Not proper convergence. So here we can say that insufficient convergence. So when there is an insufficient convergence, that means we need to add that extra converging power. So that's why we use a convex lens or a converging lens to fix the problem of hypermetropia of the desirable values, depending upon the person to person. So that, and we know that the focal length and the power of a convex lens is positive. So here we will always say positive power and convex lens. Once we are asked the questions, what should be the correction? Plus and convex. Like that, you will be given multiple options. So then convex lens plus. Now let us try to solve this numerical. The near point of a hypermetropic person is 50 centimeter. And what is the nature and power of the lens required to enable him to read a book placed at 25 centimeter from the eye? So always remember, in this case also, U remains at minus 25 because actual, where should the object be? And the near point will act as your V. And both U and V are negative. In the previous case also, both U and V were negative for obvious sign conventions that we have done in this chapter already. So 1 by F is equal to 1 by V minus 1 by U. So this becomes minus 1 by 50 minus 1 by 25, right? So if we go on solving this, we will get minus 1 by 50 plus 1 by 25, which will be minus 1 plus 2 by 50, which is equal to 1 by 50. So basically the focal length is 50 centimeters. So already you can say it is coming out to be in positive. Naturally, we know that because it's the focal length of the corrective convex lens, which has a positive focal length. And so is the power. P is equal to 1 by 0.5. The reciprocal, which will be plus 2 diopter. So the positive sign indicates that the convex lens is required. I hope this was clear, and this will make sure most of the numericals from myopia and hypermetropia are taken care of in the board examinations. Thank you so much.